Welcome everyone to our channel. This video demonstrates the principle of connecting various devices to the smart home system. Introduction. In homes without automated systems, lighting is typically connected through a wall switch that, when pressed, completes the circuit, turning on the lights. To implement the smart home concept, the switch is moved to the electrical panel, where it is replaced with an electronically controlled relay. Now, a microcontroller can activate the relay, which closes the circuit, turning on the lights. The wall switch is connected to the controller, and upon receiving a signal from it, the controller sends a command to the relay, closing the circuit and turning on the lights, allowing you to control lighting in a familiar way. Light and motion sensors are also connected to the controller, enabling the automation of lighting based on their readings. The system decides whether to turn the lights on or off depending on the sensor data. The controller is connected to the internet, allowing the application to have authorized access to the system, view sensor readings, and control the actuators. The modules have universal relay channels and input channels to which various devices can be connected. Connecting devices may require the use of multiple relay or input channels. Next, we will examine the principle of connecting various devices. Lighting. For connecting standard lighting, relay channels are used to turn the lighting on or off, closing or opening the circuit. Multiple light fixtures that operate synchronously can be connected to one relay. If low voltage lighting with a power supply unit is used, the voltage can be supplied through the relay. The relay closes the circuit, providing voltage to the power supply unit, which in turn converts it and supplies it to the lighting. If multiple groups of low-voltage lighting are used, a single power supply unit of sufficient power can be used. The output of the power supply unit is connected to relay channels, through which the lighting is connected. By closing the circuit, the relay supplies voltage from the power supply unit to the lighting. Dimmable channels allow adjusting the power delivered to lamps, leading to changes in brightness. This type of dimming is suitable only for lamps that support this type of control. The lamp packaging or description should have a symbol or label dimmable. If the lamp is connected through a power supply unit, it must also support dimming, indicated by an appropriate symbol or label. For dimming lighting or backlighting operating on 12 or 24 volts DC, PWM outputs are used. A PWM output contains an electronic switch that closes and opens the circuit 400 times per second. By adjusting the duration of voltage supply and absence, the brightness of the lighting can be changed. If the power of the PWM output is insufficient for connecting the load, additional current amplifiers are required. Fixtures supporting the DALI bus can be connected to a common network and integrated into the smart home system using the DW DALI device. The DW DALI module automatically scans the bus and adds the discovered lamps to the system. Fixtures supporting 0 to 10 or 1 to 10 volt voltage control can be integrated into the smart home system using the DW010 module. Philips Hue or IKEA bulbs can also be integrated into the system by installing a plug-in, requiring no additional hardware devices. Thermal actuators. Thermostatic heads for the heating system or radiant floor heating are connected similarly to lamps. In the case of using 24-volt thermostatic heads, a 24-volt voltage is supplied to the relay channels from the power supply unit. Electric underfloor heating is connected to relay channels through contactors. Contactors are used to switch high power. The control module, by closing the circuit, supplies voltage to the contactor, which in turn closes the circuit, for the electric underfloor heating. Locks. Electronic locks operating at either 24 or 220 volts are connected similarly to lighting. Depending on the lock type, the module needs to be configured to provide an opening pulse of the required duration. Curtains, blinds. Drive units for blinds and curtains can be simplified as two motors, one for opening and the other for closing. The drive must have limit switches that disconnect the motor when the end position is reached. To control such drives, two relay channels are used, one for supplying voltage to the opening motor and the other for the closing motor. It is crucial to configure the module correctly to avoid simultaneous voltage supply to both channels, which could damage the drive. Parallel connection of multiple drives is also not allowed, as the voltage generated in one drive can affect the operation of another. We recommend using drives with power control that do not have built-in controllers. Drives with built-in controllers usually have a port for connecting external control buttons, which can be connected to relay channels. In this case, the drive is powered separately, and relays are used as dry contacts to send opening or closing commands. Garage doors. Garage doors have their own controller, which typically allows the connection of one or two control buttons, using one or two relay channels accordingly. The channels are used as dry contacts, sending the controller the command to open or close. In the system, these channels are configured as single or double pole gates, respectively. Valves. Water supply control valves, three-way valves, or dampers are generally divided into two types of control. The first type involves a single relay channel and opens or closes when voltage is applied or removed, configured in the system as a single pole valve. The second type is connected similarly to blind drives using two relay channels, one for opening and the other for closing, configured in the system as a double pole valve. Fan coils. A fan coil unit typically has one or two valves for supplying hot or cold heat transfer fluid, as well as a motor rotating a fan with multiple windings of varying power. The fan speed changes depending on the winding receiving voltage, and power should be supplied to only one winding at a time. To connect the fan coil, relay channels are needed for connecting thermostatic heads that switch the heat transfer fluid supplied, as well as relay channels for the number of motor windings to control the fan speed. Standard fan coils have 3 to 4 speeds and 1 to 2 valves, requiring the use of 4 to 6 relay channels for connection. It's important to configure the module correctly to avoid simultaneous voltage supply to multiple motor windings, which could damage the fan coil. There are also fan coils with motors operating on 12 or 24 volts DC. PWM outputs, for example, from the DW-RGB module, can be used to control such motors. Some fan coils may have a built-in controller that is operated by 0 to 10 volt voltage or another method. Buttons, switches, and reed switches. Buttons, switches, and reed switches are connected between the input and common contacts. The input module can be installed in either a wall space, example BW-SW06, or in the distribution panel, example DW-SW16. Backlit buttons. Our system supports the use of buttons with 3-volt backlighting. The backlight LED reflects the state of the actuator to which the button is assigned. One LED can be used to display only the on or off state, or two LEDs of different colors can be used to display both states. For example, When the actuator is on, the button will have a green backlight, and when off, it will be red. The backlight LEDs are connected in parallel and are combined with the button contacts, so a backlit button uses 2 wires for connection and occupies 2 input channels. Not all modules support the connection of backlit buttons. See module descriptions. In most cases, the built-in backlighting of buttons is designed for 24 or 220 volts and requires modification to work with our equipment. 24-volt buttons. Most manufacturers have buttons with 24-volt backlighting, and for integration, the BW-SW24 module can be used. Up to 6 buttons and 6 backlight LEDs can be connected to the module. Backlighting with both common anode and common cathode is supported. KNX integration. Buttons and thermostats working in the KNX standard can be integrated into our system using the DEMG Plus module, which connects to the KNX bus. A KNX power supply unit is also required to provide power to the KNX bus. To program buttons and thermostats, a KNX interface, USB or Ethernet, and the ETS program are needed. Equipment must be assigned group addresses in the ETS program before being added to our system. Leak sensors. Leak sensors FWWL, EWWL, WWWL have a 3-wire connection and are connected to modules such as Metaforsa or DWWL02. See the full list of supported modules in the sensor description. The DWWL02 module allows configuring sensor settings such as sensitivity and backlight color. Discrete motion sensors. The discrete motion sensor CWMSD has a 3-wire connection and is connected to the discrete inputs of modules such as Metaforsa. See the full list of devices supporting the connection of discrete motion sensors in the CWMSD sensor description. Temperature sensors. Several types of temperature sensors can be used for temperature measurement. Digital temperature sensors based on the DS18B20 sensor, such as FWTS, FWFT, and WWTS. They have a 2 or 3-wire connection and can be directly connected to wall modules such as BW-SW06 or distribution panel modules like Metaforsa, DWHC10, etc. Different modules may have different maximum allowable cable lengths. Analog temperature sensors, NTC, with resistance from 5 to 15,000 ohms can be connected to modules like DWHC10, DWIO. Modules such as WWHTL, CWHTMLI2, CWCO2 have built-in temperature sensors and connect to the CAN bus. Wireless BTHD sensors operate via Bluetooth protocol and connect to the system through modules DEMG Plus or BTCAN. Infrared IR control. A remote control for household appliances, such as a TV or DVD player, sends a set of infrared flashes when the button is pressed. These flashes can be likened to Morse code, informing the device which button on the remote is pressed. Our system can read and memorize these commands using the IR receiver built into DEMG modules. On demand from a script or user, the corresponding command can be reproduced by the infrared transmitter built into modules such as CWMLI and CWCO2. The device receiving it will interpret it as a command from the original remote. Commands are stored in the system, and control of appliances can be done from the application without using traditional remotes. Air conditioners. Air conditioner remote controls transmit an infrared command containing complete data on the operating mode, fan speed, temperature, and vanes position of the air conditioner. Memorizing and later reproducing this command will fully restore the air conditioner's state. To turn on the air conditioner in an arbitrary mode, The command data needs to be decoded, the parameters identified, and an integration script created. Our system includes a database of ready-made integration scripts for various air conditioners, and our technical support service can create integrations for other devices upon request. A specialized module, BWAC, compatible with most Daikin and Mitsubishi air conditioners, is available in our system. This module is installed inside the air conditioner, connected to its control board and the CAN bus, providing bidirectional communication with the air conditioner. For integration, third-party devices such as Coolmaster or Intesis can be used, requiring the DW-RS485 module for connection. Ventilation. Most ventilation units integrate through a universal RS485 interface and the DW-RS485 module. To determine the availability of an RS485 interface and the interaction protocol, contact the suppliers of the ventilation equipment. A universal script for ventilation unit integration is available in the scenario database, and when adding it, the control register addresses from the ventilation unit's protocol description should be specified. Media points. The MediaPoint FEMP can play content from the home media library, internet radio, TuneIn, Spotify, or audio from a smartphone using AirPlay technology. The MediaPoint connects to a 24-volt power source, the local network, and 2 speakers. The USB port allows connecting an analog or optical audio signal converter for both input and output. The MediaPoint and power supply can be installed in the ceiling space near the speakers. Each MediaPoint is independent and interacts with the overall system, receiving and executing commands from scenarios, buttons, or the application. You can add as many MediaPoints as needed to the system. Multimedia integration. Our system supports integration with media devices supporting the UPnP DLNA protocol, allowing control of playback. Equipment can be controlled using IR commands, RS-232 interface, or TCP UDP protocols. Cameras. Our system supports cameras with the ONVIF protocol and can detect and add them with minimal system settings. Other cameras supporting RTSP or HTTP, HTTPS video streams can also be manually added to the system. If the smartphone is connected to the local network, the connection with the cameras occurs directly between the smartphone and the cameras. In the case of remote connection, the video stream is transmitted through an encrypted channel from the camera through the base unit and the cloud to the smartphone without requiring a static IP address or port forwarding. The application, depending on the camera model, allows control of its position, zoom, and infrared illumination. Intercom. The Intercom FEIC enables both local and remote communication with visitors and features a built-in RFID and NFC card reader. The Intercom connects to the local network and supports both passive PoE and active PoE 802.3AF. Third-party intercoms supporting the SIP protocol can also be integrated into the system. For their integration, a SIP accounts provided by our company should be used. Internet connectivity is required for the operation of third-party intercoms. Wall panels. The wall-mounted touch panels LCP4 and LCP10 use Ethernet connection to the local network, operate on 12 volts, and run on the Android operating system. The Larnitech application starts automatically and can be used with both the standard interface and an interface adapted for wall panels. Other devices. Our system supports the following standard protocols enabling the integration of various third-party devices: RS485, Modbus RTU, Modbus TCP, RS232, UART, TCP, UDP, HTTP, HTTP's requests get, post, put, 0 to 10 volt or 1 to 10 volt input and output interfaces, dry contacts, DALI protocol for lighting control. In this video, we've only highlighted some of our integration capabilities. If you have additional integration requests, please reach out to our technical support team. Thank you for exploring our instructional material. See you in the next episodes!